Welcome back to another exciting episode in communication and navigation systems. This time we're going to jump into instrument landing systems together with some of the other systems that you actually may find in this area being tested on. So without further ado, of course, instrument landing system, shorthand is ILS. There are two basic types of instrument approach procedures, either precision approaches and non-precision approaches. The difference is that precision approaches gives the pilot vertical or descent guidance, while non-precision approaches do not. Signals from VORs and NBTs, and of course that's our directional indicator, our very VHF omni-range and non-directional beacons. So those type of signals that you get from the ground, you can actually use in an ILS system. Very similar, but they've also got some additional signals. The standard type of precision approach system used in the U.S. and most of the world for civilian aircraft is the ILS. Okay, I'm sorry, I might have misread the prior paragraph there. Signals from the VORs can be used for non-precision approaches. If it's going to be precision, you use these other materials that you can actually see in the illustration. There's a definition for glide slope. That's the portion of the ILS system. Usually there's three portions. You can see the illustration shows you the marker beacons. There are the middle marker, the outer marker, and they kind of show an indication, which we'll see this in other diagrams, of what of the area in effect that the radio signal is sent from the ground. You can see there's one radio signal as the plane is higher in the air, covering a broader area, and then this middle marker shown in the yellow is when the plane is much closer to the ground. And some airports, they actually have a inner marker also. Transmitter, approach lights, nothing else there. Alright, here's a little description of the instrument landing system. In this illustration, you can see the outer marker, the middle marker, and do they show an inner marker? Not on this one. They show the localizer, which sends out a signal from somewhere beyond the landing area, and that sends out this signal, which actually is split into two. We'll talk about that a little bit later on. And then the glide slope transmitter, its partner is also transmitting a signal here, which is actually has to do more with how with the vertical difference between where the plane should be in relative to the ground. Another illustration of the localizer. So we did see that the transmitter of the localizer is beyond the runway, and it will assist the pilot to get on a direct path with the center line of the runway. They're showing that as a 90-degree. and it sends it out approximately 18 miles out. Localizer does use the same receiver antenna and receiver as the VOR, and a lot of times you will see the VOR localizer antenna just referred to together. But they do operate on different principles. It just so happens they take the same space on the radio waves. Okay, I think that's all we need to know about that. The marker beacons, we've already discussed the outer and the middle. There's an illustration of an inner. That's on the largest airports, the ones that actually have augmented landing systems, which I guess is a part of this. Some fun facts: the outer marker beacon transmitter is located between 4 and 7 miles from the end of the runway. So that's out here in the blue. So 4 to 7 miles out. The middle marker is it's about, what's that, 2,000 feet out? And they're not really showing here. All right, so basically when the aircraft is above the blue signal, his instrument panel will show a blue light, and likewise with the middle and the inner. And somewhat be aware of the frequencies, I guess. These don't look like the ones you really have to worry about. But for your own personal information, the outer is 400 hertz, the middle is 1300 hertz, and the inner, if there is one, is 3000 hertz. So basically it gets progressively, the frequency increases the closer you get in. And I believe there is a problem that mentions the systems that way. The glide slope, basically it is sending out signals, and the aircraft will know if it's on the correct angle of descent. And here you can see if you're a little too high, your 90-degree hertz signal theoretically comes in louder, but it's actually the difference between the 90 and the 150 just shows up on a dial. So if you're in the correct area, you're going to get a positive indication. But if you're too high, I think you will actually hear something that's if it's down here, it says fly up, and if you're up here, it says fly down. Okay, the indicators in the flight deck, and then the antennas on the outside of the aircraft. So they're basically showing you what the indicator looks like. You can see the one that has the localizer and the glide slope actually in one. So the pilot can pretty much use the localizer so they're on the right side. They're on the right angle. In this case, it's 31.5 degree bearing to the center line of the runway, and then the glide slope is going to indicate whether or not this circle is going to be too high or too low. So it's kind of nice having it in one. And of course, like we said before, the VOR antenna is also VOR LOC. So you're going to see them referred to together. In this case, what they got glide slope. Is that what those are? Is it the glide slope extensions? That's usually not the glide slope antenna that you are being quizzed on. So just be aware of that when you do see an antenna like that, and we do have some in the lab, that it's VOR, localizer, and glide slope. And then the marker beacon antennas, which are installed on the bottom center line of the aircraft, look like extensions of the fuselage a little bit. Here's several examples of localizer and glide slope antennas. Now this is the glide slope antenna that we're normally tested on. This one is in the radome, or the nose of the aircraft, and with the two lights on either side, it almost looks like a tongue or something like that. So glide slope, I usually think of this also. It's a dipole. Sometimes that would come up. Yeah, this one's a Canadian jet. The audio control panel that the pilot uses basically has ILS included. The markers, you can see the three different color of the markers. And I'm sorry, I kind of presumed this was going to be ILS. It doesn't. I don't see that this controls various speakers. Okay, that's what it would be. Speakers in the microphones, but you don't usually use those for ILS. This is just for your marker beacons here. Which I guess the text is basically saying the same thing. All right. The purpose of a localizer is to A, set the airplane on the proper approach angle to the runway. B, indicate the distance the airplane is from the end of the runway. Or C, align the airplane with the center of the runway. We're talking a localizer. A says approach angle. Now, that's not exactly what a localizer is, but that might be more of what the glide slope is. So if you think of glide slope as an angle, you won't actually get them mixed up. So localizer basically gets you on the right location, not necessarily the right angle. So distance, no, and that is of course C. To align the airplane with the center of the runway. To locate, localizer, the airplane to the center of the runway. There is part of the instruments can actually read the distance that you are from the end of the runway, but that's not the purpose of the localizer, but that information can still be gathered. And I'm not sure if it is from the localizer transmitter, but luckily they don't ask us all that. All right, so we talked about it. What's the purpose of a glide slope system? Is to provide automatic altitude reporting to air traffic control. That's more of the transponder. And altitude, that'd be more a mode C. B, indicate the distance the airplane is from the end of the runway. They always want to give you that distance. I would say it's not the right answer for this one either. Or C, assist the pilot in making the correct angle of descent to the runway, the glide slope, the sloping angle. Kind of like a ski slope. Your angle of descent. Oh, angle of descent. Nice. All right, why are two antennas usually required for an ILS system? Okay, we saw an example or two of where they actually combine them, but that's not the usual configuration. That's quite a big antenna, as you can imagine, and you don't really see those on aircraft. So mostly because it would be too bulky otherwise, but no, the correct answer would be more like they are not on similar frequencies. That's been a while. I would say that it's because they're on different frequencies. Yeah, different frequencies. What information does the glide slope beam provide? So again, it's the slope. So when we think slope, the ski slope, we're thinking angle of descent as being part of our answer. This one here, though, because I've reviewed this quite a few times, asks, as opposed to angle of descent information, I believe the correct verbiage that they're looking for is it provides a vertical assistance, vertical course assistance or information. Sorry, it's been a while. Vertical guidance to enable the aircraft to maintain the correct descent angle. Just get some of the right words in there and you'll do fine. Which of the antennas showed is the typical glide slope antenna? And that was the one with the two eyes on either side, the lamps. So it was one that looks like the tongue for the glide slope. So 2 is A. Okay, I guess that's going to be all you need for ILS. GPWS, Ground Proximity Warning System. It's basically a radio signal that goes out, and as you can see with the bottom illustrations, there's two types, standard and then enhanced. Basically, there's signals being sent from the aircraft to the ground, and not really showing a radio signal going forward, but that's in effect what enhanced does. It not only looks below, but it looks ahead. Looks ahead, that's what they even call it. Look ahead terrain alerting. So radar, monitoring the radar altimeter. The standard altimeters are the sensitive type. The radar is the one that actually uses a radio or a radar signal to see how far you're actually from the ground. And you will actually get auditory warnings in a commercial aircraft, or I should say transport category. So it'll either be terrain in the yellow, I'll pull up. You'll hear them testing it a little bit if you're sitting in the by the cockpit. All right, that's GPWS. There's not much that we even cover with that. There might be one question. That's why I'm going through it. Oh, here's the one question. In the landing configuration, GPWS typically monitors the radial or the radar, altimeter, air data computer, instrument landing system, and A, aileron, rudder, and elevator positions, B, landing gear and flap positions, or C, spoiler, slat, and stabilizer positions. All right, when would ground proximity, mostly if you know that they're talking about ground proximity, what would a system like that be mostly concerned with? If it's showing it, you're getting too close to the ground. Probably the strongest one would be B, because warning, we're getting close to the ground. But yes, the flaps are extended and the landing gear is extended and the flaps are raised. The other ones are more in-flight controls, so those wouldn't be monitored. Those would stay the same irregardless of your landing configuration. Okay. No, nothing new there. This might be an older presentation. It looks like I've got a couple different explanations up here. No new. Normally I would have deleted these additional ones. Okay, the next system is TCAS, Traffic Collision Avoidance System. It's a computerized avionics system that reduces the danger of mid-air collisions between aircraft. Does so by monitoring the airspace around the aircraft independent of air traffic control. The FAA requires TCAS on all commercial turbine-powered transport aircraft with more than 30 passenger seats. Must have TCAS. There was a mid-air collision, I think a congressman over the Grand Canyon or something like that, which that made it required. And it works a little bit like GPWS. Only instead of the ground, it's monitoring for intruders. Just kind of be aware of it. Let's see if there is a question on it. This is what the TCAS antenna looks like. Usually it'll say do not paint. I don't think we need the detail on the TCAS antenna installation. Certainly, if you're going to be installing antennas, you're going to follow the appropriate manufacturer's instructions. An older system is LORAN. That stands for Long Range Aid to Navigation. It's a ground-based, and it's basically dates back to World War II. And there's a signal that's sent out, so you're able to navigate mostly nautically. But you could see from the illustration the planes were using it also. It broadcasts on the frequency of 100 kilohertz. That's pretty low. The EM waves produced are ground waves. Each transmitter uses a tower about 1,000 feet tall and has an output power of approximately 4 million watts. And I think the only reason we even talk about it is because there's traditionally been a question on it. Some of these questions may have been dropped, but just in case. So LORAN systems determine aircraft location by. So how does the LORAN system works? A, measuring the inertial forces acting on the aircraft. B, means of pulse signals transmitted from ground stations. So far I like that one. Or C, means of signals transmitted to and from navigation satellites. Which, to be fair, if they didn't write C in there, I would have wrote it in as D. So I guess it could be a tough question. Be aware that those systems, LORAN is an older system. Think of satellites as being newer. And certainly measuring inertial forces, let's think of that as a newer technology also. We haven't talked about it much, but we do have some instruments that just measure the inertial forces that are acting on the aircraft. But it's not LORAN. So B. B, yes, okay. Area navigation, RNAV. That basically it is a way of deciphering signals from these various waypoints. Well, you take a couple actual signals and you're able to triangulate phantom points in space. The system will actually create one for you, and you can kind of set your own navigation through the area. And so these blue little waypoints, they're not really signals that are being transmitted, but your aircraft is actually using them to go from point A to point B. And it's basically using some real information from the VOR or the airports themselves, or the VORTAC over here, or this VOR over here. Theoretically, in the old days, you would have had to fly from waypoint or from VOR station to the next one, especially if it's cloudy and it's also not the newest technology. Indicated a little bit by the equipment that you see that is actually being used for that. I don't think you're going to run into these that much, but just be aware. Okay, it's VORTAC based. So VORTAC is the VOR, but it's also combined with the TACAN station, which is more of a military. So it may be, it does say general aviation aircraft. Oh, who knows? Transponders, that was the false answer in one of the other ones, communicating with air traffic control. You can see by the picture the air traffic controller, with their typical radar screen there. It's kind of a small picture. You basically have a transponder code which is plugged in the aircraft. You can see what the panel looks like. It's a 4-digit code. So how it actually works is the aircraft, well, the ground station says, "Who are you?" The blue signal. It's interrogating. It's saying, "I see somebody," and as soon as the plane receives that interrogation system signal, it is programmed to send a response, saying, "Oh yeah, this is what is that? 00400." Sorry, it's really small, isn't it? It helps, because around the airport it's pretty dense, and there's the possibility of accidents are much higher. Uh, so air traffic controller is trying to keep everybody in a nice orderly fashion, and they need to know who's where, and that's why we mentioned the mode C before, where it actually gives ATC altitude information. So if there's another aircraft coming in from the same direction but at a much higher altitude, it can differentiate between the two and see that they're not actually going to collide. Radar beacon transponder. Not sure why I'm calling it that. Looks like a regular transponder to me. I'm not sure what C is. Well, let's see. The lightweight digital transponder. Oh, the control head is A. Yeah. And then this looks a little heavier than it is apparently. It's a lightweight, the actual transponder. And the remote altitude encoder ICs. So for the mode C, this is the device that adds the altitude response to the ATC interrogation. That's probably TMI. Yeah, maybe not. All right, so we're going to look at the actual regulation for transponders. It's under Part 91 and Section 413 basically requires that you not use a transponder unless it's been tested and inspected in the preceding 24 months. And it also makes reference to an additional appendix under Part 43, our maintenance chapter. And we've already seen a few appendixes there. So Appendix F is going to cover the actual specifics of the transponder test. All right, the test must be conducted by probably not an A&P. A certificated repair station, a Class C radio rating, which is higher than what our avionics section is going to include. A limited radio rating appropriate to the make and model transponder to be tested. This might be a little too much information also. I think the main thing you want to see is the 24 calendar months, maybe a reference to Appendix F, and maybe the 91.413 itself, if for at least a short period of time. Yeah, I've just gone over this so much. I'm just now seeing the reference to Appendix E, which is more for ELTs. But I don't think it's anything that we're going to probably cover the next screen. So let me look at that. Okay, we've been talking about transponders, and normally these are mounted on the bottom of the aircraft. I should have probably turned this picture upside down. It just doesn't look like they're on the bottom. Yeah, now what the heck? Guys will just have to bear with me. Should I do that to all three? Yeah, why not? All right, lovely. In general, the purpose of an aircraft transponder is to... What's the purpose of the transponder? Transponder is to communicate with ATC. Okay. I guess we don't have to go much further than answer A, but let me see if the other ones are in the ballpark. B, monitor aircraft speed. A transponder? No. Altitude perhaps, but not speed. C, receive an interrogation signal from a ground station. Okay, I like that too. And automatically send a reply back. So let me see what was wrong with A. Continually transmit heading, speed, and rate of climb. Yeah, again, it doesn't. The speed is not part of it. I'm sorry, I jumped on that just because I saw ATC. So basically, go through all three to make sure you don't jump on a quick answer. C. At what interval must an ATC transponder system be certified? Do we remember that one? Yes, we do. We looked at that. That was actually in 91.413. The requirement was 24 months. Must be inspected and certified pursuant to Appendix F of Part 43. But I don't think that you need to say all that. Every 24 calendar months. Describe the shape and location of a transponder antenna. You just saw me turn them upside down. So where's the location? On the bottom of the aircraft, the bottom of the fuselage, center line. The shape, most of them were the little blade type, but I did see a little ball and post. Okay, see what the real answer is. Either a short blade or a short wire and a ball end located on the bottom of the fuselage. All right, that's going to conclude another one. How are we doing on time? All right. Time to take another break. I'll see you on the next one.